Hello everyone. Today I want to go through more questions on double slits and diffraction grating. In the last two videos, we practiced some questions on double slits. But what diffraction gratings are? Diffraction gratings, a large number of evenly spaced parallel slits called diffraction grating. It means if I have this plane with a lot of slits in it, all evenly spaced, not like my drawings, so it's a diffraction grating. They produce an interference pattern very similar to the one formed by a double slit, but their pattern is sharper. It means their bright regions are narrower and brighter, and their dark regions are darker. The analysis of a diffraction grating is similar to that of a double slit. So let's go through some questions to see how it works. First question. So we have a double slit with a slit separation of 10 micrometer. So D still separation is 10 micrometer. It means 10 times 10 to the power minus 6. That is equal to 10 to the power minus 5 meter. Used with two monochromatic light sources with wavelengths of 410 nanometer and 608 nanometer. So 410 nanometer, 608 nanometer, we convert that to meter. It means we times that by 10 to the power minus 9 meter. And the screen is away from the slit with 2 meter away. So it means L equal 2 meter. What's the distance between first order maxima of these two lights? So it means M equal 1, and they ask us about delta Y2 minus delta Y1. So in my previous video, I explained a formula to solve this type of problem. Just I summarize the question here. So I write the formula that you need to use in order to solve this problem. So the formula that we use is M lambda divided by D equal delta Y divided by L. That delta Y is the distance between the, for example, for this case, because our M equal 1, first order maxima from the central maxima, the distance between first order maxima and central maxima, we name it delta Y. So we use this formula to find the delta Y for both wavelengths. So M equal 1, and then lambda 1 is 410 nanometer divided by D, that is 10 to the power minus 5, then delta Y 1, and then L equal 2 meter. As a result of this, delta Y1 is 820 times 10 to the power minus 4 meter. I do the same things for lambda 2, again 1 times 680 times 10 to the power of minus 9 divided by 10 to the power minus 5, but this delta Y2 and 2. As a result, delta Y2 equal to 1,360 times 10 to the power minus 4 meter. As a result, delta Y2 minus delta Y1 is equal to 40 10 to the power minus 2 meter. Okay, let's go through second part of the problem. At what position on the screen other than central maxima? Because we know at central maxima we have constructive interference for all wavelengths. So, but the question asking at what position on the scene other than central maxima do the maxima of these two wavelengths first line up? So if the maxima of these two wavelengths overlap, it means delta Y of them are equal. So it means delta Y for lambda 1 equal delta y2. So if I use the formula, again, we know D equal, D for both of them are equal, and L also equal. And then I write M2 lambda 2, again the same, delta y2. But as they said, we want them to overlap. It means delta y1 should be equal delta y2. Okay, as a result, if delta y1 equal delta y2, it means the right side of these two equations are equal. As a result, their left side also should be equal. So it means m1 lambda 1 divided by d equal m2 lambda 2 divided by d. Or we can say m1 lambda 1 equal m2 lambda 2, and or lambda 1 to lambda 2 is like m2 to m1. So 410, 680 equal m2 to m1, or we can say it's equal. If we divide these two, we get this 2. It becomes 0.6, that I can write it 6 over 10. But because they ask two wavelengths first line up, so I simplify this one by 2, and it becomes 3, 5. So it means when M2 is equal 3 and M1 for M1 is equal 5, they overlap. What does it mean? It means third order maxima of lambda 1 line up with fifth order maxima of lambda 2. Let's go through next question now. This question is about diffraction grating. So we have a diffraction grating with 625 slit per 1 millimeter. It means when we say 625 slits per 1 millimeter, it means 1 times 10 to the power minus 3 meter. In this space, we have 625 slits. As a result, we can find separation of a slit using that. 1 millimeter that I converted to meter divided by number of slits in that. That is equal 1.6 times 10 to the power minus 6 meter, or I can simply say 1.6 micrometer. So we have this number of slits. The screen is 3 meters away. So we have our L equals 3 from the diffraction grating. What would you observe? Okay, so you do this experiment, you use the diffraction grating with these characteristics, and then you, with a white light, and you use a white light source. So you have a white light source, you shine it on diffraction grating with this characteristic, and you have a screen 3 meters away. You want to see what you observe and account for your answer. As you know, a diffraction grating can separate different wavelengths with high resolution. Okay, so all wavelengths have constructive interference at the center. So at the center of a screen, all different colors or different wavelengths, they have constructive interference. So it means at the center, we have a central maxima, which is white. However, the higher order maxima for different colors do not line up. Therefore, the different wavelengths get separated and create a rainbow pattern. Remember, the angle for violet color is smaller than red color. Why? Because we know, we learned that m lambda, we have a formula, m lambda, again, I explained that in my previous video, d sine theta. As a result, when lambda is larger, it means the angle is larger, and because we know violet light has a smaller lambda, it means the theta for violet is smaller. This is about part A. Part B, calculate the angle for the first order diffraction. Again, m equal 1. They're asking to find this angle for first order diffraction for wavelengths of 380 nanometer. So it's not that difficult. So the only thing that we need to do, we need to use this formula, the sine theta. So because it's first order 1, definitely we need to write our wavelength in meters. So I converted nanometer to meter. D is equal to 1.6. We calculated that, 10 to the power minus 6 sine theta. As a result, we can put this in calculator and find our theta, that is 13.74 degrees. Okay, right now let's go through second part of the question. The third part actually. Calculate the distance between the ends of the rainbow of white light. What does it mean? Because we said that it's except for central maxima that we can see a white color, in both sides we see a pattern like rainbows. Why? Because diffraction grating can separate different colors. Okay, so the question is calculate the distance between the ends of the rainbow. So it means if we have a screen like this. This is central part. This is central maxima. And then we have separated different color here. Let's say here we have red, here we have violet. And they're asking us to calculate the distance between violet and red for third order interference. Okay, let's see how we can solve this part. So for doing that, we know the lambda 1 here, as the question said, is 380 nanometer for violet, and lambda 2, that is for red, is 760 nanometer. Definitely, we need to convert that to meter quickly, times 10 to the power minus 9 times 10 to the power minus 9. And again, I use the formula m lambda d delta y L. Why I'm using that? Because they're asking me to find delta y. So I use this formula for both lambda 1 and lambda 2. But this time my n is 3. Why? Because the question asked for third order maxima. So simply just I substitute number in this for lambda 1 and lambda 2. When I find delta y for lambda 1 and delta y for lambda 2, I can just deduct them to find what's the separation in the rainbow pattern. So I write 3 for lambda 1. I start 3 times 380 times 10 to the power minus 9. Divide by 1.6 times 10 to the power of minus 6. That is our separation. We already calculated that. Delta y1 and separation was 3. I do same things for lambda 2 quickly. And then that's it. 1.6 times 10 to the power minus 6 equal delta y2 divided by 3. I calculate my delta y1, that is equal 2.137 meter. My delta y2 is equal 4.275 meter. The question asks what's the distance between these two, delta y2 minus delta y1. So it's equal 2.137 meter. Thank you for watching.